Hello and welcome to another lesson in Python. We are starting a series, or we are continuing a series we started last week. And this series is titled Data Manipulation with Pandas. When you start learning Python, you will move to an area where you start learning about certain libraries. And some libraries are very, very important to help you achieve a whole lot in Python. So we looked at a library called request, and we were able to scrape data from the web. We looked at multiple libraries for automation and other things. And right now we are looking at a library for data manipulation. This is so powerful. Understanding pandas, what we are about to learn, is actually going to be what will give you a foothold in Python, especially if you work in the data profession, a data analyst, data scientist, machine learning engineer, or you work in cybersecurity, cloud, and DevOps. You are going to use this to manipulate data. If you're a developer, you are going to use it to work with API, and you are going to do a whole lot with it. This is one of the most powerful lessons or powerful libraries in Python that we need to understand. Yes. So before I get into it, I'm going to give you a short motivational message that says that a year from now, you may wish you had started today. Wow, this is so powerful. Yeah, sometimes we procrastinate certain important things that we are supposed to learn or to do. We put them off saying tomorrow, tomorrow, tomorrow. And by the time you look back, 1 year has passed. And sometimes you are supposed to learn something that will take you 1 year, and you think 1 year is a long time. But before you realize 1 year is here, and you will wish that you had started. Yes, so let us start. Let us do what we have to do. Let us pay the price today, and we are going to see results. A year from now, you'll be very happy that you trained yourself. You'll be very happy that you did the right thing, and you are going to achieve a lot of results. Yes, so this is me, and I welcome you to part two of our data manipulation with pandas. This is actually the 18th topic we are treating in Python. We have all the videos there. We will be introducing an app to the specialization students to access all the live classes we've had in all the various programs and courses. So you have access to it. And of course, the root face also has an app for all the videos. And so this is the second lesson. If you missed it, you can get it on the WhatsApp platform. If you don't have it, just contact any of the seniors or Benedine, and you will get access to it. And this is the part two, and a very important part of this particular topic to help us gain understanding. By the end of this lesson, you will be able to work with data, to load, filter, to explore, to clean, analyze data sets using pandas. We are going to gain hands-on experience with what is called data frames and series to enhance your skills in handling data. The world of tech is full of data. We work with data every day, and your ability to understand pandas will give you control over data. There are a lot of data analytics tasks that comes from your knowledge of pandas. There's a lot of machine learning tasks that comes from your knowledge of pandas. And so this pandas is something you have to really learn and understand. So in our previous lesson, we treated the introduction to pandas, and this is going to be the continuation. I'll do a very, very quick recap, and we will just brush up on a few things, and we'll get right into the continuation. And I hope you remember the first lesson. If you don't, you have to watch it because it will help for you to really understand this one. Now, Pandas is a powerful data analysis library in Python. So as you study the fundamentals of Python, you get to a certain level where you are introduced to libraries. And so you start importing libraries into your program. Now, these libraries may not have been developed by the Python developers. It may not have been developed by those who created Python, but has been created using the Python language for a particular industry or a particular field or a particular task. So when it comes to, let's say in the health industry, health experts have been working on certain libraries over decades. And they use Python to build that library. And now they make it open source for everyone to be able to import it and use it. So there are powerful libraries that we can use, and Pandas is one of the most powerful ones. Very, very powerful. I like the word powerful on this slide because Pandas is really, really great. If you understand Pandas, it makes your Python very, very great. If you are a Python developer, if you know Python and you don't know Pandas, then you have a lot to learn. And if you know Pandas, you have a lot of authority in Python. You have authority in Python. So we are starting a series that will slowly take us into Pandas and give us the understanding because all of us will need it in the journey ahead. So it is well suited for loading and reading data from various sources, including Excel, CSV, JSON, and SQL. When it comes to working with data, especially big data, we mentioned in our previous lessons that you can accept data into your application or into your machine learning model from various sources. But these sources are not fast enough, are not robust enough, are not dynamic enough for Python to work with it. And so what Python wants is to read this data and convert it into a very, very flexible format, a flexible format that Python can easily manipulate. This flexible format is what Pandas provides. So Pandas is like a new world where data becomes very, very flexible for Python, especially when we are dealing with large data sets and big data. And so anytime you are working with data, no matter the source of the data, you can give the data over, hand it over to Pandas. When Pandas gets it, no matter how large it is, no matter how heavy it is able to allow Python to manipulate it. This is why it is very important to use Pandas in your programs. Pandas makes it easy to split, to merge, to join, to clean and organize data sets. It is great for organizing, cleaning, and transforming data. And then Pandas has what we call some data structures. So in the previous lesson, I mentioned some data structures that Pandas works with. And I want to know who remembers. This is my first question. If you remember the data structures that Pandas work with, please type them in the chat for me. At least let me see if anyone remembers any of them. And if this is new to you, just take your time and listen to what we are going to share and learn from it and keep it because you are going to be building upon it tomorrow. Sometimes you hear something for the first time. Sometimes you hear something afresh and you are wondering how to connect it with what you already know or how to process it. Just relax and make sure you are following and recording what is happening. When we are doing the hands-on coding, you make sure you also do same, and it is building the foundation for you to begin to understand it. There are certain concepts, certain topics that it will take about 2-3 lessons for you to really get a hang of it. But then the foundations are important. If you don't build that foundation, it is going to be difficult to understand it later on. This is powerful and everyone should get this. So I can see a lot of people typing series and data frames in the chat. Now, Pandas organizes data into two main data structures called series and data frames. So in the world of manipulating data or working with data, using Pandas, your data can be structured in what is called series or what is called data frames. In all of Python, these are the terms that are used when we are dealing with pandas and data. Now, series is a single column of data with an index. And so when you are dealing with what is called a one-dimensional data set or data, in pandas, it is called or referred to as series. It can hold any data type, such as integers, float strings, making it easy to access and manipulate. A series is best for handling one-dimensional labeled data, like time series, stock prices, temperature, or categories, product type, survey responses, or numbers, sales scores, sales or scores, and then text, names, or descriptions. So all that we are saying is simple. We are saying that if in pandas, you have a one column data. Inside pandas, inside the world of pandas, it is referred to as series. It is referred to as series. Please type series in the chat for me again. Series. Now, we are used to two-dimensional data. We are used to data with rows and columns. Sometimes the data you'll be dealing with is like a list. Okay, the data is like a list. So when we started learning Python, we were introduced to certain data structures, and we talked about lists. We talked about tuples. All those data structures are one-dimensional data structures. Sometimes you will have to operate on a one-dimensional data structure in Python. Now, although lists, tuples, and sets are very, very powerful in Python, they have a lot of limitations when it comes to working with large data sets, when it comes to working with machine learning, when it comes to working with big data. They have a lot of limitations, like we mentioned last week. And so all those kinds of data or array type of data needs to be sent to pandas. So there's a way to use pandas to load your data. So if you are dealing with a one-dimensional data, you need to load it into pandas. And because it is a one-dimensional data, it is referred to as series. That is the term that is used in the Python community for one-dimensional data in pandas. When you look at a data frame, you can see that this is another term that we use for two-dimensional data. When we say two-dimensional data, we are referring to data that has rows and columns, 2 dimensions. It doesn't mean it has 2 columns. It just means that it has rows and has columns. Now, when we come back to series, in pandas, series have index numbers, and they may have a heading. All right. And then we said that they are very, very powerful than lists and tuples when it comes to high performance environments, when it comes to large data sets. This is why we need pandas to handle or to step in when we are dealing with such levels of data. A data frame is a two-dimensional table with rows and columns, where each column can have a different data type. So usually, most of the time, you'll see that series will be made up of a single data type. But then when it comes to data frames, you will see that most of the time, each column will have a different data type. And that is very, very obvious. Now, data frame is the most commonly used data structure when working with pandas. So in the world of pandas, we deal with data frames a lot. All right. So all these are examples of series and data frames. And like I said, it does not mean that they have to be two columns. So long as they are rows and columns, we refer to that as two-dimensional data. Two-dimensional data. All right. So we started a demo that we will be revisiting, and we loaded a cybersecurity data set to be able to analyze cyber threats. Now, cybersecurity professionals are also data analysts. You analyze logs, you analyze threats, you make predictions, you analyze a lot of data to be able to prevent attacks. So if you're in cybersecurity, you need to understand how to use pandas, and you need some data analytics skills. And some data analysts may even switch to cybersecurity, and cybersecurity students also need to understand data analysis skills. So we are working with a data set that is a cybersecurity log data that we are investigating and manipulating. Now, the first challenge is to import it into Python using pandas. And so you need to install pandas on your system, and then you need to import the data. So when it comes to installing pandas, the first video, we went over that, so you can refer to that. But all you need is to open to your terminal and type pip install pandas, and you are good to go if you have Python installed on your system. If you are installing it in the Jupyter Lab environment, make sure you include this particular exclamation mark before you begin the installation, and it can install for you right in your Jupyter Lab environment. To use pandas, of course, you have to import it. And everyone understands how to import pandas. Let me share my screen again and highlight one or two things for you to see. All right. So anytime you import pandas, you can import pandas as an alias. And by convention, everyone imports pandas this way. So to import pandas, you can say import pandas and it will work. You can say import pandas and it will work, but we give it an alias or a nickname and we call it PD. So if you want to give it an alias, you say import as the alias. And in the Python community, we call it PD. What this means is that moving forward, anytime you want to refer to pandas, you refer to it by the alias, and the alias is PD. All right, the next challenge is to load the data set. So this particular data set, we loaded it from GitHub, and we loaded it into our Jupyter environment. So we'll be revisiting this particular work and we will continue from where we left off. All right. So I'm going to open to the GitHub link. And if you have, you can open to your browser and also open to the GitHub link. All you have to do is to go to github.com/RitaAfrica and you have access to the GitHub platform for Rita Africa. And then there's a repository here called data. So you click on data and you have access to the data here. So the data we are dealing with is called network traffic data, and that is it right here. So we can download or import the data from GitHub or download it to our PC and import it from our PC. So we are going to look at how to import it right from GitHub. So to do that, you click on this particular data set and you can see the data set right here. So right in GitHub, you can see the table. Although it is CSV, GitHub is formatting it in a tabular form for you to see it. And if you want to send it to Pandas, the last time we just copied this URL that ends with .csv, but that will not be able to read it. And so we realized that we had to change the link before it worked. So what I'm going to do now is to show you how to fetch the raw link. All right, so please don't use this URL. After seeing the data, you have to click on this. What do you see here? If you can see my screen, tell me what I'm pointing at, and then we will click on that. Okay, so you can see raw, click on raw. Once you click on raw, it will open the raw CSV data. So when you look at this, you can see that this is a structured data, all right, but it is structured in CSV. When we started this lesson, we said Pandas is able to accept data from multiple sources, including CSV. So this is CSV. You can give this CSV to Pandas, and Pandas will convert it into a data frame, and a data frame is made up of rows and columns. So this particular data you are looking at, you can see that as you go through it, you can see comma separating the various data items. And we have headings at the top over here. And this is the raw data. If you want to import it into Pandas, make sure you are on the raw page, then you can copy this URL. With this URL, Pandas will accept the data directly. So what we did here was that we stored the data link in a variable called URL. So we stored the link in the variable called URL. And then we came here to look at the powerful line of code that is able to read the data. So in Pandas, to read the data, this is how you read it. Remember our PD. We mentioned that because of the alias, all the time you have to say PD when you are referring to Pandas. And then PD has a method, and that method is called .readCSV. This .readCSV is a method that says that we are about to read CSV data. In our previous lesson, we learned that if you are reading JSON, we have read JSON. If you are reading Excel, we have read Excel. If you are reading HTML, we have read HTML. In this particular situation, in this particular case, because we are reading CSV, it has to be .read CSV. And then we have our URL here. So this URL here is referring to the link we see over here. It's referring to the link we see over here. that we have saved in this variable called URL. If the file, this particular file, if the file is saved on your PC, then all you have to do is to enter this particular file name inside this particular parenthesis here. This is what you have to do. This particular file name, you have to enter it into this particular parenthesis here, and it will also read it. It will read it for you. All right. So if you don't want to load it from a URL, you can just save the file and then load it directly here, considering the file path as well. And so you can upload it to your Jupyter environment, or you can make sure the file is at the same location as your Jupyter environment. And what is important that we are referring to right now is this line here called read CSV. All right. So let me launch my Jupyter environment and let's look at the data, and we will carefully go through various manipulation tasks with regards to this data. Your ability to understand how to manipulate data this way is what really confirms your skills in handling data. And this is super, super useful for data professionals and anyone working with data in Python. So let me load my Jupyter environment. I will just open to my terminal and I will say Jupyter Lab. So let's run this, and Jupyter Lab will open in my browser. So it's about to start the server, and the server will start running now, and Jupyter will load. Tomorrow we'll be having our machine learning class. And so if you're interested in machine learning, please join us, because we are building machine learning models. All right. So let me switch to the network traffic data project. And this is exactly what we are talking about over here. So we're able to import Pandas as PD. We're able to read CSV. So I was able to read it this way because the file was uploaded to the same directory of the Jupyter file. We already understand that Jupyter files have extensions .ipynb. So this particular Jupyter file, you can see that it is stored right here. This is the Jupyter file I'm working with right here. And you can see that the data set is also next to it. You can see the .csv here, and you can see the .ipynb here. So because they are at the same location, you can just import it without stating the file path. It is very easy to import from GitHub. You can paste the raw URL here. And if you are pasting it, you paste it as a string. And because it is a string, you need to use the quotes. And you can store it in a variable before loading it here, or you can load it here directly. If you store it in a variable, you don't need a quote because you are not dealing with a string this time. So over here, you can see that the string is here in this URL. So because it's a variable, you don't provide the quote here. If not, it will treat the URL as a string and not as a variable. All right. So the next thing we did was to explore the data. So we did this last week. So I'm not going to spend any time here. We were able to find the shape of the data where we type df.shape. And this particular shape, you have to note that we didn't use parentheses. So we did df.shape over here. Look at how we did it last week. df.shape. So with this particular dot shape, we don't need a parenthesis. Okay, we don't need a parenthesis. So you type df.shape, and with that, you'll be able to see the shape of the data set. Now, when we say the shape of the data set, what are we talking about? What are we talking about when we say the shape of the data set? What are we talking about? Who can tell us in the chat? If you remember, if you don't, just watch the previous lesson and you understand. But what do we mean by the shape of the data set? Anybody? All right. So Esimami says that the number of rows and columns. This is very, very useful. Anytime data analysts are working with data, what they do is that they investigate the data, they explore the data. Because it is in a DF, and DF stands for data frame. Here, let me go up and show you where it became DF. Over here, when we did the pd.readCSV, we assigned it to a variable called DF. This means that the entire data set has been assigned to a simple variable DF. So this DF you are seeing here, small like this, contains the entire data. No matter the data set, how large it is, DF can still hold it. All right. So anytime you call DF, you are calling the entire data set. So when I say df.shape, I am making a request to investigate and find out how many rows and columns we have. And I'm seeing that this particular data set has 1,000 rows and has 9 columns. This gives you a lot of idea to know what you are dealing with. And this information is very, very good. Another type of information that is very, very useful is what we call .head. If you type df.head, you can see that this is a method, and so you provide the parentheses, df.head. df.head will display the first 5 rows of your data set. And so the moment you run that, you will see the data, and the first 5 rows will be given to you from index 0 to index 4. And you are going to see all the columns of your data set. This is super useful as well because it gives you an idea for you to see the names of the columns and for you to actually inspect part of the data. What is really powerful here with .head is that instead of getting 5, you can request for 7. So if you say df.head 7, let's run it. I'm getting an error because I need to start all over. So I'll go up. When I imported Pandas, it was weeks ago. So when we started just now, I have not imported Pandas. So I'll come here and run this particular cell again, and it will re-import Pandas. After re-importing it, every other thing will work now. Let me work on this. As a matter of fact, let me use the URL method now. So I'll say URL, and I'm going to pick the URL from GitHub. So I'll store the string of the URL here. So I'll just go to my previous GitHub. I copy this raw URL, and then I move here now. And what I do is that I paste it inside here, the codes. So the URL is stored here in this variable. So if I want to call it, I'll just come here and say dot read CSV to bracket URL. This is very, very simple. This is very, very simple. This is very, very simple. And again, if you are not dealing with CSV data, you need to remember that in Pandas, we have read CSV, we have read Excel, we have read HTML, we have read JSON. So if you are working with different data sources, you need to choose the right method here. so that Pandas can effectively load the data. Please type load the data into the chat for me. Load the data. All right. Also remember that there is an underscore. So if you want to call CSV, you say read underscore CSV, and then you provide a parenthesis, and then you put in your string. This string, I have stored it in a variable, so I don't need a quote. If I don't have it in a variable, I need to provide a quote and put it inside here, the file name. All right, so this is understandable. Let's run this again. And now we have the data here as DF. So we have assigned all of this to this variable. So anytime you call DF, you have access to the entire data. All right, so we can come here and say df.head. Remember the parenthesis. If you run this, it's going to work. You are going to get the first 5 rows from 0 to 4. And you are going to see all the 9 columns. If you go through it, 1, 2, 3, 4, 5, 6, 7, 8, and 9. This is really, really good. And I have it. And I mentioned that .head can let you see more if you wish to. By default, it will give you the first 5 rows for you to start investigating your data. If you want 7, you can put it here, and it will load it from 0 to 6. This means you have 7 records, and this will give you an opportunity to see how your data looks like. So already we have an idea of what we are dealing with, and we can see that there are some empty rows and empty fields, empty cells somewhere, and later we may have to deal with those empty cells. All right. If you want to see 10, you can type here and run it. And this means that from the top to the bottom, starting from index 0, you are accessing 10. So 10 will give out from 0 to what? 10 will give out from 0 to what? All right. So someone says 0 to 9. So if you check here, you see 0 to 9. All right. So this particular method or function here is used anytime or most times when a data analyst is investigating the data frame. So this DF refers to the data frame, and we are investigating it. All right. Apart from .head, we also saw that you could do .tail. And if you want to see .tail, let me click here and create a new cell up here. And then we will check what df.tail means. If you run this, .tail is also displaying something. Who can tell me what we are seeing here? Who can tell me what we are seeing here? All right. So .tails is another method or function in Pandas that is able to show you the last 5 rows. The last 5 rows. So as the head is giving you the last 5, tail is giving you the last, as head is giving you the first 5, .tail is giving you the last 5. Let's see if .tail with a number will show us what we are requesting for. So because we requested for 7, you can see that the last row, because we have 1,000 rows, always starting from 0, you know that we always have our index numbers starting from 0. So it will end at 999. Because I requested for 7, you can see that I'm seeing the last 7. These are powerful functions in Pandas, or methods to be precise, in Pandas that allows you to investigate your data. Wonderful. There is another one that is .columns. Over here, you can see .columns. It's another You can run this as well. And what this will do is to let you see the columns you have. So we did that last week as well. Let me create a cell here at the bottom and type df.column. So let's run this columns, sorry. Let's run this and we will see the columns over here. So this allows you to fetch the columns and to see the column names. So all of these help you to understand what you are dealing with. So these are the columns we are working with. All right. Now, the next task is to select specific columns for display. Having the ability to select a specific column out of your data is super important. How do you know the columns you have? You can run dot columns. Remember, dot columns doesn't have the parentheses. So with dot columns, just like dot shape, we didn't use any parentheses. But dot head, dot tail, they all have parentheses. So if I don't know the columns, I can use dot head to find the column, or I can use dot columns to find the columns, and I can choose to select only the source IP. All right, this is a major part of data manipulation. Having a large data set and choosing to select only one column for a particular task. So the challenge here is to learn how to select specific columns. So what we are going to do is to learn how to select single columns and also how to select multiple columns. And this particular task or challenge, I want you to pay attention and listen to something I'm about to say. When you look at this, you can see how we are using df over here to select the columns. You can see that we are typing df with double brackets before typing the column names, and you have to type the exact column names to select. So in this particular task, we are selecting how many columns? 4 columns. Timestamp, source IP, destination IP, and status. We want to use these columns for a particular analysis. You may not know which columns you will need for what task. And so what you have to do is to have the ability to select any column you want. After selecting, you can choose to store in a different variable. So we stored it here as selected columns. Selected columns. So let's do this, and I'm going to show you something very powerful. And so let's do it again, even though we did it last week. Let's do it again. Let me click here and press DD to delete, DD to delete, DD to delete, and DD to delete. All right, you can press DD on your keyboard if you have selected a cell and it's in blue. If it's in blue, you can delete. All right, so to select the column, look at how you do it. You type DF. DF here refers to the entire data set. You can run just DF to get an idea of the data. By just running DF alone, we have seen the entire data with the first 5 rows and the last 5 rows all showing over here. Let's type DF again. And to select, we need to use these open brackets, and we need to use 2 of them. I'm going to tell you why you need to use 2 of them. After you have 2 of them, you can now open quotes and type the names of the columns you want to select. So over here, let's say we want to select source IP. You need to look at how the column is named exactly, and you select it the right way. So with this, we will be able to select it. I'm going to run this, and you can see that I have only one column displaying here. And it is amazing that I selected one column, but I still use double brackets here. And I'm going to explain. Let's add comma and select another column. So let's select destination IP. Let's intentionally make a mistake in the column name and see if we'll be able to select it. So we got an error. This means to select a column, you need to provide the correct column name. So I put the underscore back, and then we run it again. And because we did that, we have been able to select only source IP and destination IP. If you have a data set, you may need certain parts of the data for a particular analysis. And you, the Python developer or data analyst or cybersecurity analyst, you need to know how to use Pandas to select columns when dealing with data frames. This is exactly how to do it, and you can see how simple it is. In order not to keep typing this, if we want to save this selection, all we have to do is to create any variable. Let's call it source and destination. This is so long, but you can give it any name. It's just a variable. You can call it SD. Just that we want to be descriptive. But for now, let's just say SD. Let me run this again. And the selection has been given to SD. So next time I can just call SD. And when I run SD, I'm going to see what SD is. You can see clearly that SD is another data frame that contains only the source IP and destination IP. This SD selection, I want to find out if it makes sense to someone. Do you understand how we selected those columns? Anybody in the class? Do you understand the meaning of this SD and how we selected and why we have just two columns? Wonderful, wonderful. So it is very simple to understand. You just need to do it at some point in time. This line of code, if you don't type it with your fingers, you are not going to be able to retain it. You see right now, it looks simple to you, but you have to type it yourself. And I'm going to explain some things here to make it more understandable. Now you can see that this SD is also a new data frame, different from DF. So DF exists, SD also exists now. So this SD, let's type .shape on SD and run it and see. And we are going to see this. Do you understand what we are getting? You can see that SD is a different data frame that we have created. This same SD, we can type .head, and we are going to get the first 5 rows of SD. Thank you. You can see that anytime you have a data frame, you can apply these methods to investigate it. All right, let me show you something else. This challenge says storing selected columns in a new variable. That's what we just did. Okay, we store the selected columns in a new variable. But what I want to show you here is this. We are going to do another selection, but we are going to select a single column. Now you know how to select. And then we will compare it with our SD selection and see something different. Over here, when we were selecting SD, you saw how we did it. We are going to select only source IP and store it in Pandas. Let me create another cell down here and go back to DF. DF still exists, and tell DF that give me only source IP. Give me only source IP. If I type this, I've done a good selection. If I run this, I'm going to see that it will respond to it. It has selected only one column and has selected only source IP. I can store this as source underscore IP here. Or today, let's use short names. Let's call this SIP like this, or maybe SIP. Let's run this. All right. You can see that SIP, which did a selection, did not give us an error, even though we used just one column to select it. You can see that SD also didn't give us an error, even though we used two columns to select it. Sorry, two brackets to select it. With SIP, we use one bracket to select it. Now, I'm going to ask a question before I explain. Why did we use one bracket for this SIP selection? And why did we use two brackets for the SD selection? I'm sure somebody is aware. Why did we do that before we proceed further? Why did we do that? Anybody? Understanding this will make it easy whenever you are manipulating data and whenever you are doing machine learning, especially when it comes to data splitting and all that. All right. Thank you, Francis. So Francis is saying that SIP is a series and SD is data frame. Perfect. Please watch this. Watch this. Thank you, Francis. This particular SIP here, standing for source IP, we intentionally selected only one column. When you are dealing with Pandas, your data set is in DF, you can use a single bracket to select a single column. When you use a single bracket, you are giving an instruction to Pandas, listen carefully, that this selection, select it into a series or select it as a series, or select only one column. And that one column means it is going to become a series. We learned that series refers to one-dimensional data in Pandas. So although we are fetching the data from a data frame, the data is going to become series data. And no problem, it is going to work because when we run it, we didn't get any error. Let me come back here, create another cell, and type SIP to see if we will see the data. And this is the data. We can say SIP.head. And over here, you can see that it gave us what we are looking for. All right. The point here is that anytime you select with a single bracket, you are selecting and converting a series. or converting into series. Or it is because you are aware that you are selecting a single column. So most of the time, you can see that single column selections are done with a single bracket. This means that the data is to be stored as series. Let's change this and check the data type of SIP. When we check the data type, let's print it as well. Or let's just type, we are in Jupyter, so let's see. What do you see here? Please tell me what you see here. You see series. Thank you, Francis. Now let's check the data type of SD. When you run this code, you are going to see this. What do you see here, please? What do you see here, please? You see data frame. All right. So how did it know that SD is a data frame and SIP is series? It is because the data was created with a single bracket, or the data was selected into a single bracket. That single bracket means series. This is why when you are doing machine learning and you are splitting your data, your X and Y, you can see that the X splitting is done with double brackets, and the Y, which is the output column, is done with a single bracket, because the Y is a single column, or it is the target, and it's just a one-dimensional data. And so this is how we select it. Okay, my question is, can you select this single column with double brackets? Can you select it with double brackets? Yes or no? Who can tell us in the chat? Can you select a single column with double brackets? Okay, we are seeing some yeses, and let's see if we get some no's. Okay, no one is saying no. Okay, so let's run this again and see if SIP is going to work. So we can see that SIP didn't complain. The only thing is that let's check the data type of SIP now. Watch this. Let's check the data type of SIP now. And guess what? What are we going to see? I've not run it yet. Okay, forget what you are seeing here. What are we going to see? Okay, all right. So when we run this, wow, you see 25, 25, I've run it now. You can see that even though you are dealing with a single column, it is now a data frame. Okay, this makes a lot of sense because this time, even though we selected a single column, we selected it with double this. Even though a data frame is a two-dimensional data, this time it contains just one column and it is still a data frame. And so when you are selecting and you want to select it into a data frame, you use a double column, sorry, double what? Bracket. Why do I keep saying column? And if you want to select into a series, you use this. So these are simple things to pay attention to. All right. And so you can see right here that we did the same thing here. And here too, we did the same thing. And we stored it in a variable. All right. The next task is to learn how to filter data. So with this particular cybersecurity data set, we are tasked to select only the blocked traffic. So what is that supposed to mean? This means that the data set DF, let's go back to DF. The data set DF has a column called has a column called status. Inside status, there are two items or two categories. It is either blocked or allowed. Our job right now, out of the 1,000 rows of data, we are being tasked to select only the data that are blocked. What do I mean by that? These are network traffic data that we are analyzing, and we want to see only the blocked ones. This one you are looking at is a mixture of the blocked and the allowed, but you are supposed to filter out and select only the blocked data. So to do that, I want you to use DF to do it with this particular code here, where you target the column called status and say that out of status, give me only the blocked records or the blocked traffic. So please do that and store it in a variable called blocked traffic, and then run your blocked traffic code and post it in the chat for me. So if you are following, go to DF and say that DF out of column status, give me blocked. So let me give you a minute to do it, because all that we are doing, if you don't type it and if you don't see the result, the knowledge will not go far. So please work on this. And this is called filtering. We are filtering blocked traffic. And the blocked traffic is a category. It's a category out of the column called status. So what I want to see is the data frame. So when you store block traffic, run block traffic, and let me see the data. So post it in the chat, and then we will do it over here and see it as well. So we have a few people. Okay, so we want only blocked traffic. All right. So I'm just asking for this line alone, just this block traffic, not the second line as well. Just filter out blocked traffic. So let me see anyone who has only blocked traffic. So Hillary has done a tremendous job, and you are giving us block. So you can see that under column status, we only have blocked, 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 blocked. That is super powerful. Hillary, your work looks very, very neat. All right. So let's go back to Jupyter. And let me come here and create a cell up here. And let's perform this operation here. This is asking us to filter only blocked traffic. So filter only blocked traffic. To do that, we need to go to DF and say that inside DF with our codes like this, go back to DF column status, where status is equal to blocked. So this is a code to select it. When we are done, we can store it in blocked traffic. like this. So we have assigned it with the assignment operator to blocked traffic. Let's run this and see if there's an error. There was no error. So we can call blocked traffic and see what we will get. Let me create a cell here and call blocked traffic. After I called blocked traffic, I'm seeing this over here. And if you check the status column, you can see only blocked this time. This is really, really good. And we've been able to filter out. What do you think? How many network traffic were blocked? How many rows do we have? Or how many were blocked? Who can give me that answer? How many were blocked? Okay, so Francis is telling us how many were blocked, and I'm wondering how Francis got it. What is the code to find out how many were blocked? You see, we are still analyzing the data. What is the code to find out how many were blocked? You can run .shape. Beautiful. You can run .shape. So these are simple things that you, as the analyst, need to know how to do. So blocked traffic .shape. When you run this, you get to know this is information. Okay, that is good. Is there someone who is following what we are doing and who is understanding what we are doing? Anybody? All right. So someone is understanding what we are doing. This is very powerful. Having the ability to remember how to do this by yourself is where we want to get to. And so by practicing this, this is a major part of analyzing data. Knowing how to manipulate the data sets. It is huge. It is huge. All right. All right. That is very, very good. So our blocked traffic is giving us all the columns where we have blocked, and we have seen how many we have. Okay, that's beautiful. That's beautiful. That's beautiful. All right. Let's go back here and look at this code. This particular code said that after getting the blocked traffic, we are now interested in these 4 columns. So go to your data frame that is this time called block traffic, this time not DF, because block traffic is also a data frame on its own. Go to data frame and select only these 4 columns. Go to your data frame called blocked traffic and select only these 4 columns. So please, after the first one, I want you to do this for me. Select only these 4 columns out of your data frame, the blocked traffic data frame, just these 4 columns, and display it. So let's see how you do it. I'm giving you some few minutes. I want to see who will finish in time and post it in the chat. We are looking for these 4 columns, timestamp, because we want to know when the incident happened. Remember, we are analyzing cybersecurity data, and we are interested in finding out those who try to hack the company, and those who, because our system keeps all the logs. Logs means records of all those trying to hack us, but our firewall was able to block them. So the company has contacted you, the cybersecurity experts, to find out all those who try to hack us that we blocked. Give us the time that the incident happened so that we can investigate. Tell us the source of the person's IP. and the destination IP where the person intended to attack, and then the threat level. Let me see who has been able to filter this data. You can be a data analyst, sorry, a cybersecurity analyst, and all that we have done in this lesson will be your job. Let me repeat it. What we are learning now under Pandas is a full career. After this, you can apply for a job. Of course, you need more knowledge, but this is a job. This is what someone does in a company as a security analyst to analyze the logs. Now, this security analyst needs to know Python. Why do you need to know Python? Because you need to be able to manipulate the data and investigate the data like we are doing right now, so that you can fetch any information that we need to trace the attack and know what to do. As a cybersecurity analyst, you may not be involved in other parts of security, but just to handle the data part of the security. So this is a job. After this class, the Panda series, you can apply for a job. Okay, so this is beautiful. Lorraine Otieno, you've done a great job. You have selected that perfectly. Okay, perfectly. You've done, I like how you did it. All right. So out of our blocked traffic, we need this particular for information, and let's see it. Let's see it. Let's see it. Tonight is for analysis. So I think I've also created my blocked traffic already. So what I'm going to do is to select. Remember how we did selection. And the goal of this lesson is to let you remember how to manipulate this data on your own by yourself. So this means that by the time you are able to know how to select columns, okay, by yourself, then you have this knowledge. So I've selected the timestamp, and what else do I need? What else do I need to select after timestamp? Who can tell me what else I need to select? Some of you have done it so beautifully, so beautifully, so beautifully. What am I supposed to select next? Source IP. So I will put it into a string. Remember, it has to be a string. So I'll come here, copy source IP. Then after that, I'll put a comma. Then I'll find destination IP. You don't have to see this data frame to be able to select. You just need to get the column names right. So if you remember how to get the column names right, then you got it. So the last column here I'm supposed to find is threat level. So let me go here. Okay. So this is so powerful. We've been able to filter, select specific columns. All right, let me show you something. So these specific columns that we have selected, you can see that it is a new data frame, just that we have not given it to a variable. All right. Sometimes, watch this. You can come back here and say that blocked traffic is equal to blocked traffic selection. What is going to happen when we run the code like this? Look at this. After doing the selection out of blocked traffic, we stored it back into the same blocked traffic. What is going to happen here? Who can tell me what is going to happen? Okay, so inside the chat, I am seeing someone is saying that select and assign. But what is actually going to happen when we do this? Okay. What is going to happen when we do this? It's a select and assign, all right. But what does this mean? We did a selection out of block traffic. Remember, this is block traffic. Watch this. This is block traffic here. And block traffic has 9 columns. But we have selected 4 columns out of it. And we are storing the 4 columns back to block traffic. What is going to happen? Okay, I told you some point. But what is going to happen? What is the word? Okay. So the word is that we are going to overwrite it. Thank you, Lois. Some of you, I'm so happy when I see, wow. So the block traffic now, we are going to override what we had before. This means, let me overwrite it first. This means next time, let me create a cell here. Next time, if you call blocked traffic, how many columns are you going to get? Let's run block traffic.shape. How many columns are we going to get? 4. So you can see that block traffic no longer has 9 because we have overwritten it with the new selection. All of these are simple data manipulation you can do. Okay, so it is shortened, but we have overwritten it. So now it has been replaced with a 4. Let me run block traffic again, and let's see the data itself. So now we can see that the data block traffic is made up of only 4 columns. What I'm going to ask you to do next is to filter out only I want you to filter out, because when we investigate this particular data, remember that under threat level, we are seeing 3 columns already. Okay. Next time, we will find out how to identify the categories. We have low, we have medium, and we have high. Okay. Now that we know that there is high inside the threat level, the company is asking you that after selecting block traffic, show us only the high risk traffic or high risk threats. So go to threat level and filter out only the high threat levels. That is the task. So let me see who can filter out, with your knowledge of Pandas data manipulation, how you can filter out only high threat levels. Do that, run it, and paste your code in the chat for me to see. Let me see your code in the chat. So I'm waiting for who will be able to filter fast. We have a lot of people doing the same thing. I want to see who will be able to do it. And listen to me again. All the challenges we are talking about tonight, you need to do them yourself with understanding to be able to retain this knowledge. What I mean is that this particular class, don't just watch it. Practice everything we are doing with understanding. For example, why are we filtering out high traffic? It's because we are interested in knowing the threats. You are a cybersecurity analyst. You want to know the high threats. So be interested in getting the results. As you are doing this practice, be interested in finding out who is trying to attack your company. So as you type the code in Pandas, you get the result and you see it, then you can check the IP that is trying to hack you. Ato has been able to do it. Ato, you are a senior cybersecurity professional. So let me see if Ato gave us only high traffic, and I can see high, 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 high. That is so powerful, Ato. Congrats, you've done very well. And I've seen Esimame, you are a genius. Beautiful. Wow, I like your code. Not only were you able to select the high traffic, you were able to give us the first 5 rows to make it very clean. I like that, Esimame. You are a serious data analyst. Thank you. And this lesson will really take you through what a data analyst does. What a data analyst does. So I can see Marasi, beautiful. You've been able to select the high traffic, high threats, beautiful. And then okay, someone is asking a very important question. Now, the question is about the threat level, and what we overwrote, we added the threat level. So we still have access to threat level. Okay. There are some of you, I just know that you are going to succeed. You are going to get to the top. I just know it. I just know it. I just know it. So let's do this. Okay. Let's do this. Again, with what we are learning in Pandas, if you understand it alone, you can get a job and you can start working with this. With this on your CV, you can do this. And again, I'm going to ask you to carefully work on all the challenges in this lesson in a Jupyter Lab and publish it on your GitHub as a project. This is a cybersecurity network traffic data analysis. This is a project. When we are done with this lesson, publish this project in your GitHub and if possible on LinkedIn as well. Leave it. Sometimes the simple things you do and you publish are what employers will look at tomorrow to give you a job. If a company knows that you've done this project, they know that this is exactly what they are looking for and you've done it before. So sometimes you are working on a project, you are not even taking it seriously. Package it well and publish it on GitHub and on LinkedIn. So what I want to see is that I want you to package this, what we've done, all these challenges. I want you to work on it. And what we want is a clean Jupyter notebook, okay? Everything here, even though we've named them, you will do all of them with a good heading, okay? So this project is called Cybersecurity Data Analysis with Pandas. Let's call the project Cybersecurity Network Traffic Data Analysis with Pandas. So give it a nice heading. Come here and say, make it a markdown and say that cybersecurity network traffic data analysis with Pandas. Then add a description, create another markdown with description. This project, so, and so, analyzes the network traffic data to discover threats and attacks on a company's network. Just give it a nice description. However, you will write it to suit what you are doing. Then, instead of saying challenge 1, you can just say installing and importing Pandas. Then, loading the data set. Then all of these, loading a data set from GitHub. Then basic data exploration. Then selecting specific columns. Don't name it specific columns. Name it by the particular columns you selected and make it meaningful. All right, give it a name. So selecting, make it meaningful. What I'm saying is that at the end of this lesson, let this be a project that you keep as part of your portfolio, because this is a lesson that some of you are going to get a job out of. So I would like to see this project on GitHub and on LinkedIn. Do you understand? Do you understand? Do you understand? This is your portfolio. This is your portfolio. Wonderful. Keep it. It's very important. It's very important. All right. So that is it. Now we've been able to select the high traffic. So all that I'm saying right now, you can title it with a heading, a markdown heading like this. You can add a description or probably not, and then run it, selecting high risk traffic or high risk attacks. Okay, then you run it like this. So what you are posting, you run it. So when someone goes through this notebook, they will see what you did, and each one should be meaningful. Each one should be meaningful. Yes, I'll share this slide with you all. Each one should be meaningful. So do it well. This is a very important project. All right. So we have three. Okay, we are ending at 10. So we are filtering out suspicious traffic. Okay. Wow. So what we did as high, you can see that this one is called critical. Okay. So let's run another one. And this time, let's filter out critical traffic. So this is still part of data filtering. The part of Pandas that we are now is called data filtering. So we've been able to select the blocked traffic. We've been able to filter out the high threat levels. Now we are filtering out critical threat level or suspicious threat levels. So please do that and post in the chat right now. Leave the first one, the high one. Now look for critical. Let's see how many you'll get. Let's see how many you'll get. Let's see how many you will get. Let's see how many you will get. Let's see how many you will get. All right. So you can just copy the first code. The video will come out tomorrow. Tomorrow. Bernardine will post it. And very soon we are going to give you an app where you can access it yourself. But tomorrow, God willing, Bernardine will share with you. Bernardine is your senior. So ask her. She'll give you the video. Okay. So let me see who can post the critical threats. Let's see if we have some critical data, or if we don't, no problem. Let me see if anybody has critical. Okay, so we have critical. Wow, we have critical. That's beautiful. That's beautiful. That's beautiful. I like one thing that the cybersecurity instructor told the cybersecurity students. Listen to what he said. He said that sometimes when a company wants to employ you, they don't really expect you to know everything, but they just want to know whether you've done some things before. Whether you've done some things before. Because you are entering a serious company and they have their own protocols, they have how they do their own things, and they are going to train you on how to do the work in the company. They are going to train you. But if they see your portfolio that you've done this before, you stand a better chance practically than all those with CVs saying they can do things. You see, the company doesn't really expect you to know everything or too much. They don't, okay? They don't really expect you to know everything they do, but they just want to know if you've done some things before. So your CV may not speak volumes for you, but some of the things you've done before, like this project now, will speak for you. So when a company knows that you've analyzed network traffic before, you have it on GitHub, you have it on your LinkedIn like months ago, that is really powerful. So I want to see everyone package this particular lesson as a project and publish it. And I'll be looking for it on LinkedIn and published on GitHub. On LinkedIn, make sure you tag Rita Africa and use the hashtags as usual. And then also send your work to assignments@ritaafrica.com for us to see how you did your assignment. All right. We are going to do another filtering, just like the two challenges we've done. This challenge 8 is going to filter high data transfer where byte cents is greater than 5,000. So we are going to look at our data frame. This time you are doing this on DF. Find out the data transfer. So this will definitely be under the allowed traffic. And we want to see anyone who downloaded something huge on the network. All right. Anyone who downloaded something huge on the network. So all of these challenges, if you understand what you are doing security-wise, you can give it a description before you write the code when you are working on your project. Let it look nice. I want to see who can do the best presentation out of this. This alone will give somebody a job. I can just tell you this evening, I feel like telling you that some of you are going to get a job out of this project. I want to see who will package this project nicely. Let it look professional, very, very professional. And next week, I will look at who did the best and we will celebrate that person in class next week. All right. So let's find out the data transfer, the byte sent that is greater than 5,000. So let's do this and post in the chat right now. Let's do this and post in the chat right now. This is also data filtering, just like the critical threat level and the high threat level. The same thing, just at this time, we are doing it on DF and we are doing it on the column called byte sent, where byte sent is greater than 5,000. Let me see who will do this and post in the chat right now. Let me see who will do this and put this called high data transfer. Sometimes when people are attacking, the bandwidth they consume is high. So we are filtering out those who downloaded or requested for high data on the network. So Francis, you're on point. Francis was on point. And Francis, wow, today, where's Robley? Robley, I've not seen you. I think I saw your name when we're starting. Is Robley here? Robley, today, Francis is taking over. So byte sent greater than 5,000. Wow, wow. You see, as a security analyst, you don't just write the code, but you study the result to investigate. Okay, so which IP did this? Maybe it will help us to find what we are looking for. Very, very good. Very, very good. I thought you've done a great job. You've done a great job. And as a cybersecurity professional, you know Python and you know data analysis with Pandas. This is powerful. This is powerful. Wow, that's beautiful. That's beautiful. You've done it. You've done it. You've done it. All right. We have two more and we are done. The last two I think I should leave it as assignments because this is what machine learning um, professionals do. They split data into X and Y, and X is called inputs, or also known as features in machine learning, and Y is also called target or output in machine learning. We do this so that we can do predictions with a machine learning model. So this data splitting is very powerful. And I have the code here. You can see how we created the X data frame and the Y series. You can see that Y is series and X is a data frame. You know that it's a data frame because it is capital X. And you know that it is a lot of columns. If you see the code there, you see how we are intelligently selecting all the other columns apart from threat level, and we are using Y as the output. So we are removing Y from the first and creating another series for Y to become the output variable for the machine learning prediction. This is very powerful. You need to do this. It will help you if you want to do machine learning. And then the last one is to remove a particular column. So these two challenges, I want you to add it to what you are working on and complete these 10 challenges. And these last two are assignments I'm giving you, although everything is an assignment. I want you to do this on your own. This means that next week we'll pick it up from here and we will get into data splitting and we'll be doing additional manipulations like removing columns. So it is very simple to remove a column with this code. You can see it here, and very simple to also split. And next week we will continue from here. Our Pandas series will take between 3 to 5 lessons, or maybe some additional ones to complete our studies on Pandas so that we have the full knowledge when it comes to Pandas. And you have to watch all the series to understand it because this is a job on its own. So let's wrap up here. I believe you've gotten something, you've gained from this lesson, and you've learned something. The assignment is for you to do challenge 9 and challenge 10, plus do all the 10 challenges and prepare a professional looking notebook with comments, with headings, with the codes, with the results. Do it professionally and publish on LinkedIn, GitHub, tag Rita Africa on LinkedIn, and also send it to assignments@ritaafrica.com. We are doing this because some months from now, this project will give you a job. Let this project be part of your portfolio. So I want you to go through it and do it from challenge 1 to challenge 10. Make sure you title them right, not just because we have written removing a column here. So you title it removing a column. In the project one, you have to be smart and you have to be specific as to what you are removing. Let it look like a cybersecurity project, okay? So Destiny, don't worry, you'll be added. You are new, so don't worry, you go through the process, okay? So make sure you know what we are doing. We are dropping timestamp. We are removing timestamp. So be descriptive in your titles and descriptions so that your projects will look good. The goal of that project notebook is so that an employer can go through when you apply for a job. So make it very nice. Let it be professional looking. Let it be descriptive. Let it have good documentation. All right. I want to see who can do this the best way possible. So next week, I will select the first person who was able to present this project the best way possible. You are not designing it for me, you are designing it for a future employer. A future employer may be a US company that will pay you $10,000 a month. A future employer may be a company that will pay you $15,000 a month. This is one of your projects in your portfolio. I hope you understand me. I'm going to share the slide with you, and Bernardine will give you the slide in the video. And I believe that someone has learned something tonight. Anybody, if you've learned something tonight, let me know in the chat. Have you learned something tonight? Thank you so much. Thank you so much. Thank you so much. This is why our Python classes are important. You may not know what you will learn, but if you are consistent, you will not miss anything. So keep learning, keep attending classes, and you'll benefit a lot. Tomorrow, I invite you to a machine learning class. We are going to do something wonderful. Last week, we couldn't complete something important, so we are going to go over and do it very well. And so the machine learning class is going to be interesting as well. Make sure you join us if you are a data student and you are interested in AI and machine learning. Join us and let's move forward and continue. So thank you all for going through this lesson with me. We are still on it. Next week, we'll move to the next level and we are going to upgrade ourselves. Have a wonderful evening and I'll see you in the next class. All the best. Bye-bye.